there are many parameters that I am going to define. So, the first parameter that I am defining is usable life cycles. Usable life cycles, total usable life cycles. I call it UCYC, usable life. This is a parameter that will come from manufacturer, usable life cycle. And then I will use another parameter called cycle per day, usable cycles per day. So, what is the effective number of days? Usable life cycles divided by cycles per day. And if I want to calculate in terms of number of years, including the fraction battery in years, it will be usable cycle divided by cycle per day multiplied by 365. I am assuming they are all 365 days, I am doing the same thing. Is that all right? This is the effective life of the battery in years. It may come out to be 4.73 years. So, it is so many years, so many days, you can actually calculate that. This is important, but this is what the depreciation, the term depreciation means. I start with a new full cost, at the end of life it is say 0 cost, and depreciation means if it is going to last for 4.7 years, over 4.7 years I will keep on losing linearly its life. Now, there are non-linear depreciation, but we will leave that, we will make it a linear depreciation. So, it will lose, so its value becomes 0, it starts with a value of let us say 20,000 rupees, end of life it is 0 and 4.73 years. So, you can see how it is going to impact. Usable battery cycles per day. Now, this is an important parameter. Usable battery capacity per day, usable battery capacity per day, per cycle. Now, this is if the battery is new, of course, is a C is the capacity, depth of discharge, because I am not going to use the rest of the battery, I am only going to use COC. So, C into DOD is what I am going to actually use per day, but that is what I will use when it is a new. When it is old, I will actually use C into DOD into what is EOL. So, actually I take C into DOD multiplied by 1 plus EOL by 2, this is the average. This is the average usable battery capacity per cycle. Okay. Now, this is a simplification that I do, which helps us me. For 1 kilowatt hour battery whose depth of discharge, suppose I use 0.85 and end of life if I use 0.7, 70% of capacity, the usable battery capacity per cycle is works out to be 0.7225 kilowatt hour. So, though I am buying 1 kilowatt hour or a battery, I am actually using only 0.7225 kilowatt hour on the average. When it is new, I am using 0.85, when it is old, I am using 0.85 multiplied by 0.7. So, on the average, I am using 0.7225 kilowatt hour. So, I have to actually calculate the cost that I will calculate per day for the battery will be this, not for 1 kilowatt hour. So, I have to for 1 kilowatt hour it will be more. So, effective battery costs per year given an interest rate can be obtained. Now, it is like a mortgage. I have taken loan against some entity and I know its life depreciation, I will do linear depreciation and I know the interest rate the bank charges and I want to compute what is the effective money that I have to give for mortgage payment. I can do it every year, I can do it every month, theoretically I can do it every day. And there is a very simple formula in Excel called PMT, the payment against mortgage. So, if you open the Excel sheet and use PMT, you have to give 3 parameters: the interest rate, which I just sort of said could be 12%, 16%, whatever. Now, battery years, which will come from what we have just calculated, battery years, we can calculate battery days instead of battery years. Battery days will 365 will not be there. Then it will give you the battery cost per day instead of per year, and the capital cost. The capital cost. This will be the battery cost per year. I can also calculate battery cost per month, battery cost per day. So, that will give me battery cost per year. Now, battery cost per year, so I know, but effective battery cost per kilowatt hour, because battery cost per year is this, but how much do I use per year? I use 365 into U cap. The usable cycles per day is U cycle. U cap is the battery capacity, average battery capacity, multiplied by 365 will be the actual number of the total capacity that I use in a year. Now, so the battery cost per year I have already found out, but depends on how many times I charge discharge. If I charge discharge once a day, it is simply battery cost per year divided by U cap into 365. But what if I use 2 times a day? Well, then it will come to battery cost per year divided by U cap into 365 multiplied by 2, divided by 2 also, which is same as battery. You can simplify battery cost per year, battery cost per year, that is comes from here into battery years, because I have simplified this, divided by U cap into U cycle. This is actually simplification. This is the actual cost per kilowatt hour. I have taken into account the capital cost, the interest cost, its usable cycles converted into usable years or usable month. I have taken into account number of cycles it is used per day. I have taken into account the end of life. I have taken into account depth of discharge. So, this formula battery per cost per kilowatt hour, you can just go to the Excel, do this and then just do this. This is basically a very simple, if you know all the parameters, it is a very simple calculation on a Excel sheet, and I should have embedded the Excel sheet, and I did not. I will do that, embed the Excel sheet. Now, what I will do actually, I will try to compute and see what it impacts. So, I take 4 kilowatt hour batteries, I will take 2 kilowatt hour, and let us assume the usage pattern and temperature is all fixed, C rate is all fixed. The battery 1, I will take 4 different kinds of battery, cost 10,000 rupees per kilowatt hour, very low cost battery, 1000 cycles, 90% depth of discharge, 1.5 C charge discharge, 1.5 cycle, this is charge discharge, 1.5 C, I think 1.5 cycles, I think this is 1.5 cycles of charge discharge a day, as far as I remember. I think I will double check this, I need to double check this. Because this is not right, I think it is not 1.5 C, it is not a C rate, 1.5 cycles per day. I think that is what it is. As far as I remember, I should not have written. Sorry, it is not. I think it is, their battery 1 is given as that if you charge discharge at 1.5 C rate and 90% DOD, you will get 1000 cycles. So, what I have written is right. Okay. So, these are 4 cells available, battery available. One is at 10,000, another is 12,000, 18,000 and 35,000. This can last for 1000 cycles, this is 22,000 cycles, 5,000 cycles and 10,000 cycles. And I have taken 10,000 90% DOD and charge discharge 1.5 C, 1.5 C, 2 C and 2.5 C. Actually, the numbers here are slightly underestimate, actual cost will be higher. This may, even for a large battery, the actual cost may be higher, but I have taken this example, it does not matter, we will show what actually it means. If I take this and remember that if I am only going to have a 10,000 cycles, 10,000 cycles means battery can last for 10 years, 15 years, 20 years depending on number of cycles that I use per day. So, then calendar life also may kick in, not just the deterioration due to charge discharge cycle, and I have not taken calendar life in my computation. So, I have to add that at some point of time, but one can add that. So far we have ignored calendar life. Now, so we take 2 batteries out of these 4. The first battery is 12,000 rupees, 2,000 cycle, 1 cycle per day. Another is 18,000 rupees, 5,000 cycle, 1 cycle per day. Here I am taking 1 cycle per day. Let us assume DOD of 90% and end of life is 80%. This is a little estimated to be little low cost, and actual costs are going to be higher. But with this aggressive cost, look at this. This is what I wanted to show you. Effective cost for this battery 1 is in red color. It starts around 7 rupee 50 paise at close to 0% interest. But look at, as the interest rate goes up 14%, this 750 becomes close to 11 rupees. See how badly this interest rate impacts things. This is for battery 1. For battery 2, which is a more expensive battery, but it has a large life, 5,000 cycles, look at this, this gets even worse. It is a very good battery, only costs about 5 rupees. This has not taken electricity cost, plus electricity cost. So, only 5 rupees, less than 5 rupees, 4 rupees 50 paise if there was no interest. Because of the interest, it can become almost 10 rupees. This, I wanted to point that out. The biggest determinant is interest rate. Of course, life cycles will matter, number of cycles per day will matter. As those changes, we will see things impacts. The initial capital costs does matter, but it is the interest rate that dominates the cost. And this is Europe, United States cost, this is India cost. And the numbers are not small difference, from 4 rupees to 10 rupees, 2.5 times. So, when I optimize, what do I have to do? Well, my interest rate is higher. I have to somehow figure out a sweet spot. Where do I operate? Do I keep 2000 cycles? Do I keep 5000 cycles? Do I use 1 cycle per day? How do I add cost? What do I have to do? This is the most important issue. It is the interest rate that matters. So, this is the same thing that I am showing you, impact cost for battery 1 790 to 1109. Now, actually this is not something related to battery. In many things that India uses, this is something that hurts us vis-a-vis Europe. On the one hand, the affordability in India is lower, on the other hand higher interest rate means we have to pay really. through our nose, and it's huge difference 790 to 1109, and for the second battery is worse. It is 513 to at 2% is 513, for 14% is 10.22, double the cost per kilowatt hour, per kilowatt hour. So, if you can get lower interest rate, makes a huge difference, but at every interest rate you have to optimize. What is the best thing that I can do? It is not a universal truth that we often. Now, this is something that nobody else will teach you. Now, one says, well, I won't go to the bank. Well, wherever you go to, you put the money costs, the interest rate is a reflection of what does the money cost, even if you borrow from someone else. If you have your own, fine, but you could have earned interest. So, that will be denied. So, the effective usage cost, you may say, no, the effective, my effective interest rate I will take it is only 9%, that is fine, but whatever the interest rate you assume, you need to compute the effective cost of usage of a battery. This plus electricity costs. So, 10 rupee 22 paise in India plus 5 rupees electricity, suddenly it is a 15 rupees of usage cost per kilowatt hour. So, if 1 kilowatt hour is going to give me whatever, depending on the vehicle, 30 kilometers, suppose I have a two wheeler, let us say it gives me 40 kilometers. So, my 40 kilometer may cost me 50 rupees, sorry 15 rupees. So, I need to compute that. You will find still it is lower than petrol vehicles, because the cost of petrol would be much higher. Let us do a simple calculation, some numbers for a two wheeler. Let us take a smaller size two wheeler. What is the mileage that you get? 50 kilometer per hour per liter, and the petrol, let us say it costs about 75 rupees, 80 rupees. So, it is approximately 130 per kilometer for petrol. Now, according to this, at 14% interest rate, it is a 10 plus 5, 15 rupees suppose my is the cost per kilowatt hour, and 1 kilowatt hour suppose gives me 1 kilowatt hour may give me 40 kilometers. So, for EV, for electric scooter, 1 kilowatt hour may give me 40 kilometers. So, 40 kilometers will cost me 16 rupees. So, it is only about 40 paise per kilometer. So, see this calculation. This is assuming 14% interest rate and assuming that you are not buying battery. Now, as I told you that the battery cost that I had assumed 12,000 rupees and 18,000 rupees is a little bit optimistic, and normally for 5,000 cycles you are not likely to keep it. So, it may not be 40 paise, it may be 60 paise. This includes the cost of your battery. So, if you ever talk about total cost of battery, it is 60 paise versus 1 rupee 30, it is half as expensive. But here you have to give either upfront cost of the battery, or you have to convert it into lease and things like that. The problem is banks will not give you easily the money for the battery, because they do not understand fully the usage or life cycle of the battery. That is a critical issue, but this is what I was talking about, the most important thing, and this needs to be really understood. Long term its cost is lower, electricity we can generate in India, petrol we have to import. This is a far superior solution. This is even assuming 14%. If you are in Europe and there are only 2% and maybe the cost would have been only 7-8 rupees, you would have got huge advantage. Of course, there the petrol cost also may be lower, but anyway, that is in Europe it is not, US it is. So, do you understand? And the reason I try to calculate, let me take another one, and this is what I took for all the 4 batteries, and as I told you that I have underestimated the cost of these actually costs, this is a little underestimate for all of them. Let us take depreciation, let us take 12% interest, not 14%, and I have computed Excel sheet. I have taken a battery 1 1.5 cycles per day, battery 2 1.5 cycles, battery 3 2 cycles, battery 4 2.5 cycles. In fact, you will see if I change this number of cycles per day, your cost changes quite a bit. And I have taken 90% depth of discharge and 80%, which may not be so easily doable. You may actually do 80% depth of discharge. And through this Excel sheet, then I have calculated effective cost of battery 1 comes to 15 rupees, which is similar to what you got here. At 12% interest, you got 11 rupees, but I think that is because I have taken here I have taken 1.5 cycles. So, battery 2 on the other hand comes to around 10 rupees, this is also 1.5 cycles, battery 3 2 cycles 677, battery 4 2.5 cycles. So, depending on my usage pattern, am I going to charge discharge once a day, twice a day, 3 times a day? Normally a person may charge discharge only once in 2 days, then I have to take that, make that as a 0.5. But this simple Excel sheet which has actually calculated each of these parameters. I am going to give you a homework problem to build this spreadsheet. All the equations are here, there is nothing, this is all that you need to do. This is the parameters that I am using there, these are the 5-6 parameters that I am using. Battery cost per year, battery life per year, usable battery capacity, end of life, depth of discharge, you put this in and you get it. So, battery 1 costs at 12% 1447, battery 2 costs 10 rupees, battery 3 costs 677, battery 4 costs 8 rupees. So, you will see this 5000 cycles really makes a huge difference. This is because if I am using 2 cycles per day, if I do not use 2 cycles per day, this will not, and 2 cycles may not be so easy, 2 times you charge discharge may not be, but in a personal vehicles no, in a taxi yes. So, that is what will come to. Note that battery cost does not include the cost of electricity, and we will see next interest costs makes a huge difference. So, well, we have already seen that in the earlier slide. Battery usage costs depend not just on capital cost of the battery, but also its effective lifetime, which and heavily on interest rate prevalent in the country. Battery usage helps us compare multiple batteries with different capital cost, life cycles and interest rate. You must keep interest rate. You will certainly find that at 2% interest rate, one battery is better, at 12% another battery is better. Number of cycles of usage per day also has to be taken into account. Interest rates between India and West vary, different results. There is some uncertainty in life cycles, actual usage, because actual life will depend on certain actual usage condition. You can do a factor saying that well 5000 was what it was supposed to give me or 2000 was supposed to give me, effectively I will get about 80% of that. You can only estimate, because you do not know what the temperatures will be, and this is something that has to be learned. This is what the banks or those who lease battery really want to give it to you. Enhancing life cycles and reducing capital costs more important in India to make EV affordable. Okay. Ideally, I should change a more realistic cost. This is a little underestimated cost, but gives you the trend of what has to be done. So, here is a assignment. I have taken a battery which cost 1 lakh rupees, and suppose it uses 3000 cycle and only use 1 cycle per day, use 0.9 depth of discharge and 80% end of life. Let us assume battery capacity is 10 kilowatt hour, 10 kilowatt hour is 1 lakh, which is again little bit low, and let us assume interest rate is 12%. Use the PMT in Excel to compute usage cost per K battery. So, just do exactly that what that table is, write down the formula and then compute that. Use the approximation discussed. Oh, there was an approximation discussed earlier in chapter 1 on what the PMT will be. PMT, I should have brought that here, that PMT can be approximated. PMT will require to do use Excel sheet. What if you do not have a computer and you do not have an Excel sheet? You can still estimate PMT, and in the introduction chapter I had given you an estimating of PMT. So, I am saying use the approximation discussed to compute usage cost per kilowatt hour. Now, assume the life cycle of the battery is impacted by calendar life by 1% per year. So, now you have to redo that formula, assume that 1% per year also you are getting impacted, redo the Excel sheet. This will require work. Solution to this would be to determine lifetime, determine percentage degradation due to calendar life in the same period. So, EOI will now increase by that much percentage. So, suppose you sort of say that calendar degradation, you compute the approximation number of years. So, it is the approximate number of years for depreciation is 5 years, and so calendar life will actually take it down by 5%. Now, the end of life you are taken to be, let us say 80%, now you have to take it to 85% and redo the calculation. Okay. So, that is what the last point will like you to do. Any question? So, I should have brought that from chapter 1, that approximation out here. Well, it is there in your notes, please look at it. I could have given you a slightly more realistic picture. This 10,000 rupees is very aggressive, you will not be able to do that, but that is a target that I give it to Kaushal. Cells have come down for 1000 cycles, has come down to $100 per kilowatt hour, $102, but that still by the time it lands up in India it will be 8,000 rupees. So, very difficult to make a battery and sell at 10,000. It will be more like I think 12,000-13,000 could be the aim. So, it was a little underestimated, but it does not matter.